taxicab geometry. The idea is that it's the distance between 2 points is not measured on a straight line, but on horizontal and vertical lines, as if traveling the streets of a perfect city, hence the name taxicab geometry. In Euclidean geometry, we learned that an equilateral triangle is equilateral and equiangular. However, in taxicab geometry, although the equilateral triangle has equal sides, it is not equiangular. We learn in Euclidean geometry that an isosceles triangle has congruent legs and congruent base angles. In taxicab geometry, an isosceles triangle has congruent legs, but does not necessarily have congruent base angles. In this triangle, we are considering this side here measuring 6, and this side here measuring 6. The base angles would be the 90 degrees and 56.31 degrees. Okay, let's talk about how we can prove two triangles are congruent in Euclidean geometry. We've learned the 5 postulates you see here are ways that we can prove two triangles are congruent. Well, what implications exist for proving triangles congruent in taxicab geometry? Can we use those same postulates to prove two triangles are congruent? Let's take a look at side, side, side. Will this hold true? Here are two triangles with congruent sides. Let's take a look at what their angles measure. Okay, we can see that the angles are not congruent. Side, side, side cannot be used to prove triangles are congruent in taxicab geometry. Okay, how about angle, side, angle? Let's consider these two triangles. Look at the angles measuring 63.43 degrees and the included side measuring 2. On the red triangle, the corresponding angles are here and the side measures 2. So are all the other parts of these two triangles also congruent? Well, we can see that they aren't. In the blue triangle, the other two sides measure 3, and in the red triangle, the other two sides measure 2 units. Side, angle, side. Will this hold true? Okay, in the purple triangle, we have sides measuring 3 and 4, and the included angle is 45 degrees. In the blue triangle, the corresponding side and angle measure the same. However, the remaining 2 angles are not congruent in both triangles. Okay, what about angle, angle, side? Let's consider the angles measuring 63.43 and 53.13 and the side measuring 2. In the red triangle, we have congruent angles and the side measuring 2. Are all the other parts of the two triangles congruent? Well, we can see here that the other two sides of this triangle measure 3 and the other two sides on this triangle measure 2. They are not congruent. Okay, how about in right triangles, the hypotenuse leg postulate? Okay, here's a right triangle where the hypotenuse measures 4, the leg measures 3. Here's another triangle where the hypotenuse measures 4 and the leg measures 3, but you can clearly see that the angles are not congruent. Okay, to summarize what we've learned about the differences in Euclidean geometry and taxicab geometry with regards to triangles, we can do a compare chart. Okay, so in Euclidean, an equilateral triangle is also equiangular. The taxicab equivalent statement is an equilateral triangle is not always equiangular. In Euclidean geometry, an isosceles triangle has congruent legs and congruent base angles. In Taxicab, an isosceles triangle has congruent legs but not always congruent angles. In Euclidean geometry, if all three corresponding sides are congruent, then all parts of the triangles are congruent. In Taxicab geometry, if all three corresponding sides are congruent, then all parts of the triangle are not always congruent. In Euclidean geometry, we know if two corresponding angles and the included side are congruent, then all parts of the triangles are congruent. In Taxicab geometry, we learned if two corresponding angles and the included side are congruent, then all parts of the triangles are not always congruent. Okay, in Euclidean geometry, we also learn if two corresponding sides and the included angle are congruent, then all parts of the triangles are congruent. However, in Taxicab, if two corresponding sides and the included angle are congruent, then all parts of the triangles are not always congruent. In Euclidean geometry, if two corresponding angles and a side are congruent, then all parts of the triangles are congruent. In Taxicab, if two corresponding angles and a side are congruent, then all parts of the triangles are not always congruent. And finally, the hypotenuse leg theorem. If the hypotenuse and a corresponding leg of right triangles are congruent, then all parts of the right triangles are congruent. But in Taxicab, if the hypotenuse and a corresponding leg of right triangles are congruent, then all parts of the right triangles are not always congruent. So we have learned that none of the postulates that we know in Euclidean geometry can be used to prove two triangles are congruent do not hold true in Taxicab geometry. Thank you for